All right. Anyone have preference? Hard proofs, homework questions? Just yell if you have something, because this is really more of an informal, what do you need type thing.
Hard proof.
Hard proofs. Which one are you looking at for that right now?
Honestly, really any of them.
Okay.
Yes.
So the first two we did in the group activity. So do you want me to kind of skip those?
Mm-hmm.
Okay. Let us take a look. Let's kind of look at question 4 to begin with here. Question 4 is similar, and there's different ways to think about it, kind of like question 1. So when I did the live session yesterday in the, or if you watch the video, we said if there's no formula for sine of 3x, we can think about that as sine of x plus 2x and use a sum and difference formula on it. So kind of thinking the same way on this one, on question 4. How could I get started using that same kind of thought process?
You could do like sine of 2x plus 2x.
Mm-hmm. And honestly, that one kind of comes easiest to me because for some reason it's easier to think about it as an addition problem. There is another way when it's an even number to think about it. You can think about it as sine of 2 times 2x. In other words, like a double angle identity. I can do that, of course, but I find that kids have a little bit more trouble thinking of a double angle, if that makes sense. Any preference as to which way I'd go? Or, I mean, I can show both.
The addition one.
The addition one? Okay. So if I go to my sum and difference formulas, that's going to use 2x as both my alpha and my beta. So my sine addition formula tells me that this expands into, I believe it's cosine 2x, sine 2x. Is it minus in that formula? I always say this, and I should know better. Let me see. I have my formula sitting here. Juggling all my papers. So my sine addition formula tells me it's sine of alpha, cosine of beta. So I messed that up already. There we go. Sine of alpha, cosine of beta, plus cosine alpha, sine of beta. So using both 2x's as my alpha and my beta, I can go ahead and work through that one. So on that then, again, this is proofs. We're always looking at the answer. I'm also not going to forget that this was over sine of x from the original problem, which I didn't include yet, but we will use that. If I am looking at my answer, okay, my answer is in terms of all single x's, not double x's. So I'm going to have to make multiple replacements on the top, but I also want to look at my answer in terms of which replacement should I make. So for sine of 2x, I only have one option, right? What can I put in place of sine of 2x?
2 sine x times cosine x.
Okay, 2 sine x, cosine x. Cosine of 2x, I have options, but looking at my answer, which ones should I probably choose?
Maybe 2 cosine squared minus 1.
That is where I would go because my answer is in terms of cosines. And that could end up being not true, and I need to use one of the other ones to cancel it out, the signs out, but I'm just going to go with my gut on that one. Now, I can do that replacement twice for both these two and both those two, or essentially what's really true about both of those terms. They both have a sine 2x and a cosine 2x, so I could combine like terms and just say there's 2 of those terms out front and multiply all of that by 2. Or I can do the replacement twice and add them together later. Really doesn't matter.
I'm a little confused. Can you go over that step again, please?
Which
Sorry.
part?
Just like all of the blue. I'm sorry.
No, that's fine. I'll just go back a step here and see where we go from there. Let's just, before I make replacements, what's true about this term and this term?
They both have, they're the same.
They're basically the same, right? So that means before I do any replacements, let's just make life easy on ourselves. If you add 2 terms together that are the same, like if you're adding x plus x, it gives you what?
2x.
2x. So if I'm adding these 2 terms together that are the same, it's going to give me 2 sine 2x cosine 2x. Does that part make sense?
Yeah.
Okay. Then I'm going to go after replacing the 2 x's. So for that term, to replace that, I'm going to keep the 2 out front, and I'm going to look at my formula sheet and say sine of 2x is the same as 2 sine x cosine x. Then for cosine of 2x, I'm going to look at my formula sheet and say for double angle identities, I have 3 options for cosines. But if I go over here and look at my answer that I'm trying to get to, I know I'm trying to get everything in terms of cosines. So I'm going to purposely say I'm replacing cosine of 2x with 2 cosine squared x minus 1. Because I want everything in terms of cosines. Are we all kind of okay up till there?
Mm-hmm.
Yeah. Because those are the double angle identities, right?
Yes, those are from your double angle identities. Exactly. Anyone see something that will happen kind of nice for us right now?
Can you cancel out the sign?
Yes, because right now everything is multiplied together. Like, yes, there's a minus sign in here, but it hasn't been distributed. So before we do any of that, it would be really good to just get rid of those signs. So from there, if I'm simplifying, now that 2 times 2 in the front is 4.
You still have a sign left, right?
What's that?
You still have 1 sign left since there was like 2 of them?
No, because that's literally 2 times sine times cosine. So
Okay.
that 2 is just kind of a coefficient out front, and it is all gone now.
Okay.
Okay, so then I have a 4 times a cosine that I'm going to distribute to a 2 cosine squared minus 1. So if I distribute that, 4 times 2 gives me 8. Cosine times cosine squared will give me what? Cosine
To the
two,
third. To the third.
yep, which happens to be the answer
What
that
were the things for?
you can get that exact same answer if at the beginning you think about the sine of 4x as sine of 2x and make it a double angle identity. I don't know if that would confuse anyone to see that, so I'd have to show that, but you can get the same answer either way. Maybe that's something
Can be quicker.
It might be slightly quicker just because the sum and difference has so many pieces to it. If I treat that like a double angle identity, I would say double angle identity works to sine or 2 sine of x cosine x, but if it's double a double angle, it would be sine of 2x cosine of 2x instead of, because we're going from 4x down to 2x, and then you'd have to replace both of those. But it's essentially going to give this step that we had here. So I honestly really don't know faster. I would stick with what makes sense. And honestly,
Okay.
that tends to make more sense, the splitting it up into an addition problem. I can look at 3 or 5 if anyone has any preference here.
Can we do 5?
5, actually, if you don't mind me going back to 1 before I do 5 to remind you of something, because otherwise,
Okay.
you're gonna look at me like I'm crazy.
Like, I don't remember the cube formula, but I think
That's exactly it. So
that makes me frustrated.
I know, because we love the cube formula.
I do not love the cube formula.
You actually look at, let me share this, on page 210 in your notebook. 210, question number 13. That's kind of where we would have started for something like this in class. The sum or the factoring a cubic. This is your formula for this. So that's your sum of cubes formula. To do a difference of cubes, you just switch these two signs. The first one becomes a minus and the second one becomes a plus. So using that for something like question 13 right here, it makes the top factor pretty easily into sine plus cosine, and then sine squared minus sine cosine, I'm running out of room, plus cosine squared, all over what was on the bottom here, which was sine plus cosine. So what happens to my sine plus cosines, top and bottom?
Cancel.
Cancel. And then all I'm left with right now is
1 minus that.
So I have sine squared minus sine cosine plus cosine squared. Well, this turns into that 1. But my point on that one is if you don't know the cubic formula on that, it's like literally impossible. Or less impossible, more just a total pain in the patootie to do that kind of question. So that being said, the question that you were just asking about, number 5, on your hard proofs, which I will pull back up again. Look, guys, I'm getting good at sharing my screen with the right thing. We're learning new things. I was teaching my mother-in-law how to do Zoom yesterday for Louisville ISD. She was like, I don't know. These kids online. I was like, oh, I'm on week 3. Here we go. All right.
She's ready.
Yes, I am ready. So using that same exact kind of thought process here, we're going to treat that like a sum of cubes, only really because it's to the 6th power. You kind of have to think about it as cosine squared raised to the 3rd and sine squared raised to the 3rd. Because in order to use your sum of cubes formula, you have to know what is your A and what is your B. In other words, what is being cubed. So I always have to write it this way in order to plug it in correctly.
Yeah.
Your cube formula says A plus B, so cosine squared plus sine squared. And then A squared, what would be A squared?
Cosine to the 4th.
Sine to the 4th plus A times B, so cosine squared times sine squared plus B squared, or wait, I missed a minus sign in here. That's going to be a minus right there. Plus B squared, so that's going to be sine to the 4th. All right, so that just made like a kind of mess, but at the same time, some things are going to happen nicely here for us. What do we see? One thing should be obvious.
Oh, cosine squared plus sine squared.
Yeah, cosine squared just turns into a 1, which really, because it's in a multiplication situation, kind of gets rid of it, right? So really, I care about this stuff. Now, looking at that stuff and looking at my answer, I should at least have a decent idea as to what things I need to change out right now.
Just get a lot of signs.
I need to get every
only signs.
So my goal is to get rid of that and that. Now, one of them is easy to think of. right?
1 minus sine to the fourth.
Okay, you can't do 1 minus sine to the fourth because it doesn't work that way, but I can think about cosine to the fourth as cosine squared times cosine squared, right?
Mm-hmm.
And if I think about it in terms of cosine squareds, what replacement can I make for cosine squared?
Sine, 1 minus sine squared.
1 minus sine squared. So anywhere I see a cosine squared, I'm going to replace it, with 1 minus sine squared.
Can you not square the Pythagorean identities?
You can, but it doesn't turn into 1 minus sine to the fourth. You have to actually FOIL it out.
Oh.
So this is my replacement for cosine to the fourth. Then, which I'm nicely gave myself some space here, I'm going to do minus and make this cosine squared also 1 minus sine squared. That's multiplied by a sine squared. I would still have my plus sine to the fourth. Now, this is a little bit icky, but really what all do we have to do in here?
Combine
I just have to
and multiply.
combine like terms, and I'm probably going to be at my answer. So I would start with foiling these two together. So foiling those two, 1 times 1 is 1. I would have minus sine squared minus another sine squared plus sine to the fourth. Here, I kind of have to be careful. I'm distributing this sine squared, but I also have a minus out front that I need to think about distributing. So that's going to give me minus sine squared and plus sine to the fourth if I'm doing that. And then I have this leftover plus sine to the fourth here. So from here, it's just combining like terms. I have a 1. I have 1, 2, 3 sine squared, so minus 3 sine squared. And I have 1, 2, 3 sine to the fourths, which is my answer.
Great. Thank you.
And I'm assuming we'd like to take a look at 3 as well. Is that pretty accurate?
Yes.
On question 3, which side would you start on?
The left?
The left?
Maybe the right. You could replace things on the right.
Good, but the left is definitely more complicated.
Yeah.
I would start with that. Just generally speaking, on the left-hand side, anyone have any thoughts about, whoops, that's a sign, excuse me, where we could get started?
Common denominator.
And that's a really good thought, because if you're thinking about it, this has a plus sign in 2 terms, and my answer has technically one term, because they're multiplied together. And that's exactly what you want to do. So currently the 2 is over 1. If you want to get a common denominator, what do you have to multiply that left fraction by?
Square cosine.
Sine squared.
Squared cosine, squared top and bottom. So it would look like 2 sine squared y cosine squared y plus that sine to the fourth plus cosine to the fourth all over sine squared y cosine squared y. Now I could have shown another step in there in multiplying the top and the bottom, but I could also just state multiply top and bottom by the same thing to get common denominator. Now this up here should look somewhat interesting to us. Any thoughts?
Could you break up the sine to the fourth and cosine to the fourth into sine squared and cosine squared?
So you're kind of hoping to like break it down into factors, or are you thinking like split them into sine squared or 2 sine squareds?
Yeah, split them into 2 sine squared.
You
Got
could. Let me write something for you right now to see if this would help. Does that look like something we've done before?
Factoring.
Mm-hmm. Now, currently, the way that one stands, it's not in the format that we're used to. But if I move stuff around, it might work a little bit better. So if I shift that around to make it sine to the 4th plus 2 sine squared cosine squared plus cosine to the 4th, and let's just ignore the bottom for a minute. Think about factoring that. Sine to the 4th, you would, in factoring, split it into what?
Sine squared plus cosine squared.
Okay, so I'd do sine squared and sine squared in the first one. Cosine to the 4th, I would think plus cosine squared and plus cosine squared. How do I check if this works for factoring?
You
Check,
could multiply it back out.
right?
Outer and the inner.
So sine squared, cosine squared, sine squared, cosine squared. If I added the outer and inner terms together, it would give me 2 of the same term, right? So we can take that top and factor it into that. We keep the bottom the same. What do both of those turn into?
1.
1. And 1 times 1 is just
1.
So I have 1 over sine squared and cosine squared. 1 over sine squared can turn into
Secant and cosecant.
and cosecant. Which is our answer.
Nice.
All right. Those kind of make sense?
Yes.
Just struggling to remember those things.
I know.
Mm-hmm.
They're kind of, well, here's the upside. The upside is that there's only so many ways I can make this difficult, if that makes sense. So chances are you're going to see something very similar to one of these 5, if that makes sense.
Mm-hmm.
There's
Yes.
types of factoring. There's some different, like, so like 3 and 5 were kind of similar. 3 had the added, like, get a common denominator first, but 3 and 5 both just had a weird form of factoring within them. 1 and 4 both had splitting the sign into 2 different things using sum and difference identities, and 2 was using the sum and difference identities in a different way, foiling, factoring, that kind of thing. I can't tell you which one you're going to see because based off of test integrity, I made lots of versions of tests and randomly assigned. So couldn't say who's going to get what, but lots of fun. So other things that you guys want to talk about or things you don't know and other homeworks or anything like that?
Are there any other
Good.
factoring formulas we should know?
What was that?
Are there any other of the factoring formulas we should know, like with the cubes and the 4?
The cubes was the weird one that none of us remember. It's just how it is. Like I remember that one in high school. It just doesn't happen often enough until I was doing it. Then I forced myself to remember. But no, the other factoring stuff, as long as you know different squares, basic factoring, I would know the cubic one because if something like 5 came up, you might be a little bit stuck without it. So yeah, I would know the cubic one.
Okay.
And honestly, with the test, So here's how we kind of have to approach stuff. We cannot assume that everyone's going to go honor system and that it's not going to be open note. Because that's like, we've talked to colleges and stuff, and like the way they're designing stuff right now is kind of assuming things are open note. Let's see if we can make sure that we know you know what you're talking about. So that's part of the explaining stuff. I can say memorize the trig identities, but I can't force it, that kind of thing. So that's kind of where we've gone with that. It's going to be more like you showing and explaining what you know. But that means it's going to be shorter. So the test for me is only 5 questions. So your explanations are going to be like heavy on that.
Okay, and then for mine, like for my explanations, I would just be like distribute or like plugged in a Pythagorean identity. Like it doesn't have to be extremely specific.
No, it does not have to be anything specific. And I'm going to be completely honest, because here's the thing. We spent in the last couple of days, like as a team, the math department, looking through PhotoMath, Mathway, some of the big ones that people tend to use. If you're using language that comes up in there, like the polished math language, I'm going to be a little bit more concerned. I would rather hear like plug in this than distribute, or like things that I can hear in your voice that you would have said. You know what I mean? It's easier for me to be like, yep, that sounds exactly like Macy talked. You know what I mean?
Yeah. And then for the identities, do we have to just memorize the Pythagorean and the basic ones?
For the test, I have just given an identity sheet.
Yes.
If you are taking AP Calculus next year, you need to have all the way through the double angles memorized. So I would try to do that. No one really requires you to memorize the sum and difference ones. If that is something that you're trying to do, I have a sheet that instead of using the front sheet of the test, I can give you one and you can practice memorizing them. But like I said, I can't assume that people aren't just going to look at their notes and copy them down. So there, at some point, I have to ask myself, why waste my time grading something that I'm pretty sure a lot of people are just going to copy down. So I'd rather grade the actual proofs, because I can tell already with the explanations on the quiz, some of the people that I was concerned about using apps got very, very stuck on this quiz. So, you know.
Go, Miss Leinecker.
Yeah, tricky. I'm not like intentionally, like I have not turned anyone in. Other teachers have so far. So there is that, because there's the whole cheating and zeros, and when you come back, you can start with a suspension thing.
Ooh.
Which I have not angled after that yet, but we shall see.
Well, thank you.
Anyone have other questions you want me to look at? I mean, I can pull up the homework, other stuff.
I don't have any more.
No.
Let me look real quick.
What's that?
Let's see. I'm just going to look and see if I have any other questions that I wrote down.
Yeah. And honestly, if you're studying for the test and have not done page 210, if you can figure out like the tricks to the hard proofs and you can sit down and do page 210 for the most part, you are going to be golden. Like totally fine. That's my advice.
Okay. So page 210 has a lot of good practice.
210 has a lot of stuff. It has getting common denominators. It has substitutions with Pythagoreans and other and foiling and factoring and all sorts of good things on page 210. I think 210 gives you like every different thing other than the hard proofs that I could throw at you on the test could be on 210, a version of it.
Okay.
And I don't like, here's the other thing. If you have done like all the proofs that I can throw at you in the notebook, we kind of run out of things to prove. There's only so you can't like endlessly write these. I can take, let's say if I'm looking at page 210, I can take question 5 and like take out the tangent squareds and make them cotangent squareds and then adapt the answer from that. But like I can't endlessly write new ones. So eventually you will have done so many that some might show up on a quiz or a test that you've done already. Not that you're 100% going to memorize the proof, but like you may remember things. And that's not, don't think there's something wrong with that, because we've done so many of them, hopefully, that you start to remember things. Any specific questions from anyone you want me to go over?
Well, the sample problems, are those as like on 209, is that as good as 210? Because those have the solutions on the other pages, which I like.
Yeah.
Okay.
And to be honest, like if you kind of check the format on some of them, like if you, let's say you do the sample problems, but you want to do something else like question number 5. If you look on page 210, there's going to be one that looks a whole lot like question 5, like cosine over 1 minus sine. Something that looks very like that could be question 3. There will always be one that looks similar to them on the opposite pages, and you can use some of the strategies from the solutions too, if that helps.
Mm-hmm.
Anyone else? Anything I can help?
I think that's it. I mean,
Sounds good.
I have one more. I don't know. I don't have like a specific question, but do you know how sometimes you say how we can multiply the denominator by like everything in the problem, and that will come up a lot?
The canceling out complex fractions.
Yeah.
Yes.
Could
That,
we know one with that?
let me find one that has that. I would say something like question. I know it came up in one of the homeworks. Let's see. Let me go back to page, where did that come up? Like question 16 on page 208, I would probably handle somewhat like that. Let me see if this is what you're talking about. Like 16 and 208, I would start with making the tangent sine over cosine, and 1 plus make the secant 1 over cosine. So the strategy here is kind of what you were talking about. If I don't like having double fractions, as I call them, fractions within fractions, I'm going to take all of this and multiply by cosine y, top and bottom. Is this what you were talking about?
Yeah.
Yeah. So if I distribute that to everything, top and bottom, I would see sine y, cosine y on the first term. The second term, the cosines would cancel and give me sine. On the bottom, I would have a cosine y. And then from there, I would say the top has a greatest common factor of what?
Sine. Why?
I'd go ahead and pull out a sine. And then my cosine y's plus 1's top and bottom cancel, which would just give me my sine for my answer. So that strategy comes up there. Let me see. On that page, it came up a couple times, I think. Where else? I saw that somewhere else. Question 3 had it for sure.
Mm-hmm.
Stuff like that. That's a good. So if I'm working through my strategies, I need to know how to get a common denominator. I need to know some factoring stuff, and I would look at the cubic one to know it for the test, just in case that would come up. And that's difference of squares, regular factoring, GCF, that will come up. Canceling out denominators like we just did. Yeah, from there, that's pretty much it. Kind of on the hard proofs, we talked about splitting things into pieces. That also kind of came up back here on question 13, where we said we don't have a formula for sine cubed, so you can think about it as sine times sine squared. And you can substitute that way. So that's kind of a strategy. The strategy of making everything sines and cosines. So in other words, like there's no perfect way to study for this test, which is going to be frustrating to some people. practice, practice, practice. Someone used the term with me, it's like a brain muscle memory, like doing enough of them that you have ideas to start with. That's really what it is, unfortunately, for some of you. But really, honestly, the people here, that's typically what you do anyway. So I'm not concerned with that. I've been overall very impressed with how this has gone, because this is not what I would have chosen to teach live online. So I actually, when this first started, thought about moving this to later in the year until it started looking like, well, what's the purpose of moving this later in the year? Because who knows? We will just keep plowing ahead and do what we can for sure. So, but, and we feel okay somewhat about stuff.
Mm-hmm.
Everyone kind of understand the plan with the test on Monday, Tuesday?
Yeah.
I'll get that email about trying to take it during your class time.
Mm-hmm.
Okay. If you have, like I said, this is not something we can like straight up require. We are very much encouraging it. And they said I can require during the 3 sections that I gave. So if you do it during your time, it's fine. But we're just trying to cut down on some of the passing information around, especially for those, like I said, the ones that come on with me here and like talk about, I don't worry about. And I feel bad for those of you doing all the hard work to be cheated out of that by people passing. So we're trying to maintain that for everyone. But if you have any questions though, anything else I can help you with, please let me know. Otherwise I'll just hop off and post this for those who weren't able to join.
Okay.
Alrighty.
Thank you.
Yeah.
Have a good weekend. Hopefully
Thank you.
Okay.
Bye-bye.
Bye.